All right, everybody, we are going to be doing the lab for Unit 3, light color and concentration. So this has a couple of different parts to it, and in the interest of time, I've done a lot of pre-setup for you. So the first thing that we're going to do is learn how to use the colorimeter. The colorimeter is this device. It is connected to a LabQuest so that you can see the value that comes out on the screen of the LabQuest. So the colorimeter has 4 wavelengths, 430, 470, 565, and 635. So the first part is to determine what color of light this colorimeter is transmitting. So we're going to open this up, and we are at 635. I'm going to insert a small piece of index paper, and I'm going to move this so that you can kind of see. It's a little flashing light down there. Hopefully you can see it, but it is a flashing red light in there. So 635 nanometers is approximately the wavelength for a red light. Now I'm going to change the wavelength to 565. 565 produces, looking in there, it looks like a very faint green light. It's a little bit hard to see, but it is a faint green light. We're going to change that to 470. And we look in there and we get a faint blue light. Again, it's kind of hard to see in there. Oh, there it is, a little bit clearer. You can see it on the back there. That's a blue light. Let's go back to the 565. There's that green light. And then there's the red light. So 635 is red, 565 is green, 470, sorry, didn't change. Let me get it to change. 470 is a blue light, 430 is a much brighter blue light. So those are the colors at the various wavelengths that will be transmitted by the colorimeter. So the first thing that we're going to do is kind of look at transmittance versus absorbance of some prepared solutions. So first of all, we have cobalt 2 nitrate. You can see that that's kind of a reddish color solution. It's a 0.1 molar. We have nickel 2 nitrate, a nice pretty green color. We have iron 3 nitrate, which is more of an orange color. And then we have zinc nitrate, which is actually colorless. So we can see how a colorless solution is going to behave. Now, to be able to read a sample, the first thing that we have to do is we have to calibrate or zero the colorimeter. So we're going to do our recordings at 430 nanometers first. We open up the chamber. We're going to take a cuvette. This cuvette has already been filled with distilled water. Okay, there are grooved sides and smooth sides. You only handle the grooved sides. I've already cleaned the smooth sides. So there is a white arrow. Smooth side goes to the white arrow. You close the chamber and you hit the CAL button for calibrate. The red light will flash. What this is doing is this is basically zeroing the balance, if you will. So now, as long as we stay at 430 nanometers, we can measure whatever we want. So we're going to do our 4 stock solutions at 430 nanometers. Be ready to record your numbers. Let's set that off to the side. Cobalt 2 nitrate. Okay, we got to give it a chance to get the reading. And it is 0.190 for absorbance, 0.190. Make sure you write that down. We'll take that one out, put in the nickel, give it a second to read, and we get 0.071 for the absorbance, 0.071. Now we do the iron. And we get 0.657 for the absorbance. Okay, last one for the 430 nanometers is the zinc. And we get zero absorbance. So that's the amount of light of that color that is absorbed by the solution. Now what we're going to do is we're going to change the wavelength. So I'm going to change the wavelength to 470 nanometers, put in my distilled water blank. I'm going to hit calibrate. Red light is done. Take out my blank. Now I'm going to read my cobalt. So the absorbance for cobalt at 470 nanometers is 0.180. 0.180. Okay, the nickel solution is 0.086. 0.086. The iron solution .548. 0.548. And the zinc, back to zero. So we're going to repeat for the 565 nanometers. Put in my blank. Calibrate. Cobalt at 565 nanometers is 0.097. 0.097. Nickel is 0.041. 0.041. Iron is 0.031. 0.031. And zinc is still zero. All right, then we're going to change the wavelength one more time to the 635. Calibrate. And take out our blank. Cobalt at 635 nanometers is 0.033. 0.033. The nickel is 0.143, sorry, 0.143. The iron interesting, the iron is zero. And the zinc is also zero. So what we use this for is to make sure that we know what wavelength to use for our dye. Now the dye I'm going to use for the video is red dye number 40. So because I'm using a red dye, I'm going to pick the wavelength that had the best absorbance for the red color. which happens to be 430 nanometers. So I'm going to change the colorimeter back to 430 nanometers. I'm going to zero it by hitting the calibration button. It didn't like it. There we go. And now I'm going to be working on the part 2, model 2, using the second data table, testing our serial dilution. Now a serial dilution takes a stock and then dilutes it a little bit and then a little bit more and a little bit more. So we should get a nice curved line or possibly a straight line when we plot the concentration that you got in the pre-lab versus the absorbance that we're going to record. So here is test tube A. This is your 7 micromolar stock solution for red dye number 40. And its absorbance is 0.079. 0.079. Now we have test tube B, a little bit lighter. Test tube B. And its absorbance is 0.053. 0.053. Now we do test tube C. Again, these have been all pre-made, pre-filled, and wiped down. Test tube C has an absorbance of 0.044. Test tube D. Test tube D has an absorbance of 0.029. 0.029. Test tube E. Test tube E has an absorbance of 0. So not enough to register. Test tube F. Test tube F also has an absorbance of 0. And test tube G, which should be, interestingly, it is a 0.062. That doesn't seem quite right. We would mark that as an anomaly when we do our graph. All right, the last piece of data that we need is the unknown. The unknown for this is Gatorade Fruit Punch. So I have already pre-filled some Gatorade Fruit Punch. We're at 430 nanometers. Let's see what the concentration of this particular dye would be. Let me rephrase. Let's see what our absorbance is going to be. Our absorbance for this unknown is 1.248. 1.248. So what you're going to do is create a curve using the test tubes A through G, plotting concentration on the X, absorbance on the Y, and you're going to make sure that that extends out above 0.1249. Then you're going to plot your absorbance of your unknown on that same line to determine the concentration of red dye number 40 in Fruit Punch Gatorade. So that's what you're going to do with that. You will also calculate, going back to data table number 1, you will be calculating the transmittance, which the equation to go from absorbance to transmittance is given in the beginning of the introduction. So on the front page, that's how you go from absorbance to percent transmittance so that you can complete data table number 1. Make sure you complete your pre-lab, your data tables, your analysis, post-lab, and conclusions nice and neat in your lab report, which will be due 1 week from the day that this was scheduled for data collection in class.